So hello guys and welcome back to my channel. Sir. Today in this lectures we will discuss about the mesh analysis. Here's in the previous lectures we have discussed about the nodal analysis, and nodal analysis applies KCL to find the unknown voltage from a given circuit. While in mesh analysis applies KVL to find the unknown circuit. So altogether there are 3 steps in mesh analysis. So altogether we have 3 steps in mesh analysis to calculate the current. Here first step is to assign the mesh currents, and the second step is to apply KVL to each of the n nodes. First step is to apply the mesh current and assign the mesh current, and the second step is to apply the KVL to each of the n nodes, and the last step is to to solve the obtained equations. So now let's take a circuit examples and then it will be clear. Suppose here we have resistor 1, this, and here we have V1 voltage. This is V2. Suppose here we have R1, R2 and R3. So in the first step we have to assign the mesh current. So to assign the mesh current, here we will have, in mesh first we have I1 and in mesh 2 we have I2. And the second step is to apply the KVL to each of the n nodes. So applying KVL here, we can write here in mesh first. Applying KVL we can write here V1, since it is going from negative to positive. So V1 minus this I1 into R1. And here R3 is common to both meshes. So minus R3 I1 minus I2 equals to 0. And in mesh second, we can write here, since the current is in this direction, so we can write here minus R3, and here again R3 is common to both, so we'll write here R3 into I2 minus I1 minus I2 into R2, and from a more negative to positive, so minus V2 equals to 0. So we have equation first and this is equation second. So if we solve equation 1 and 2, we'll get the value of I1 and I2 if the value of R1, R2 and R3 is given. So let's take one more example. So here we have one circuit this, and in this circuit we have to assign the mesh current. So first our first is to assign the mesh current. Here we have I1 and in mesh 2 we'll write here I2, and after that here we'll apply the KVL. So after applying KVL we can write it as 15 minus I1 into 5, and here 10 is common to both meshes, so minus 10 into I1 minus I2, and again here minus 10 equals to 0. And here on further simplification we can write here 15 I1 minus 10 I2 equals to 5. We have equation first, and here we have applied KVL in mesh first, and again applying KVL to mesh second. So in mesh second we have going from the current is going from this way, so we have minus to plus, so we can write here 10 minus 10. Here 10 is again common to both meshes, so I2 minus I1 minus 6 I2 minus 4 I2 equals to 0. So on simplifications we'll get here 10 I1 minus 20 I2 equals to minus 10, equation 2. So on solving equation 1 and 2 we'll get here the value of I1 and I2. So we can get here I1 equals to and I2 equals to. So the value of I1 will be 1 ampere and the value of I2 will be again 1 ampere. So you can solve these two equations using calculators. And again let's take one more example. So here we have one more circuit, and in this circuit we have to calculate the mesh current. So let's solve this. So our first step to assign the mesh current. So here we have I1 and here we'll assume I2 and again here we have I3. So applying KVL to mesh first, we can write here. So in mesh first, so applying KVL in mesh first, we can write here 24 minus, and here 10 is common to mesh first and mesh second. So minus 10 I1 minus I2, and again 12 is common to both mesh first and mesh third. So minus 12 I1 minus I3 equals to 0. So on simplification we can write here 11 I1 minus 5 I2 minus 6 I3 equals to 12. We have equation first. And in mesh second, so in mesh second we can write, since 10 is common to again mesh first and mesh second. So in mesh we can write here in mesh second minus 10 first I2 minus I1 and minus 24 I2 and minus 4 is common to this mesh second and mesh third. So minus 4 I2 minus I3 equals to 0. So on simplifications we can write here minus 5 I1 plus 19 I2 minus 2 I3 equals to 0. We have equation second here. And for mesh third, we have for mesh third. For mesh third we can write here minus 12. Here 12 is common to I1, means mesh first and mesh third. So 12 I3 minus I1 and minus 4, since again 4 is common to mesh third and mesh second, so minus I3 minus I2 and again plus 2 minus, so minus 4 I naught. So 4 I naught this is. So here I naught, and in place of I naught we can write here we have assumed, suppose here we have I naught, here we have given I naught, and in place of I naught we can write here, since I naught is common I1, so simply you can see this, here we have I naught and I2 is in this directions, and again I1 is in this directions, I1. Since I1 is in the direction of I naught and I2 is opposite to the direction of I naught, so we can write here I1 minus I2 equals to I naught, and in place of I naught we can write here minus 12 I3 minus I1 minus 4 I3 minus I2 and minus 4, in place of I naught we have I1 minus I2. So on further simplification we can get here I1 plus I2 minus 2 I3 equals to 0. We have equation third. So on solving equation 1, 2 and 3 using calculator, we can get the value of I1, I2 and I3. So our value of I1 will be I1 equals to 2.25 ampere and I2 equals to 0.75 ampere, and the value of I3 will be I3 equals to 1.5 ampere. Now let's see some conditions based on mesh analysis. So altogether we have two conditions here. Let's see what the condition are. Here mesh analysis with current source. So in the first conditions we have when current source exists only in one mesh. So here we have the first conditions when In mesh analysis, current source are the first condition when current source exists only in one mesh. So let's take one circuit examples and let's solve this. So here we have given this circuit. So our first step is to assign the mesh current. So here we have I1, I2, and here we will assign I3. Here we have 10 ohm current, 2 ohm resistors, 8 ohm resistors, 4 ohm resistors, and again 6 ampere current given here. So applying KVL, first we apply KVL to mesh second. So in mesh second, we can write here minus 8 I2 minus I1, I2 minus I1, and minus 4 I2 minus 2, here 2 is common to both this I2 and I3. So first 2 into I2 minus I3, 2 into I2 minus I3 equals to 0. So on simplification we will get here minus 14 I2 plus 8 I1 plus 2 I3 equals to 0. We have equation first. And from mesh first and mesh second, from mesh first and mesh third, we can directly write, we have in mesh first we have I1 equal to 6 ampere already given. So we have 6 ampere, and in mesh third we have already given 10 ampere current. In mesh first we have I1 equal to 6 ampere, and in mesh third we have 10 ampere current given. So on substituting value of I1 and I3 in this equation first, we'll get the value of I2. So on substituting, we'll get the value of I2. So we'll get the value of I2 as I2 equals to 4.8571 ampere. So let's see the second conditions. We have the first condition was when current source exists only in one mesh, and we have the second condition. So the second condition is based upon the super mesh. So we have the second condition when a current source exists between two nodes. When current source exists between two nodes, means we have here we have to use here the concept of super node. Suppose here we have one resistor this, again resistor this, and one voltage source is here, and one resistor and one current source is here, and again one resistor here. And here suppose here we have 6 ampere, this is R1, R2, R3 and R4, and here we have 5 volt given, assume. So first we will assign the mesh current I1 and I2, and here 6 ampere is common to both I1 and I2, means a current source exists between two nodes. So here discard these elements. So these elements will be discarded. So here discard these elements. So if you discard these elements, then now we will have the single mesh here. So we will apply the single mesh from here to here, means this terminal will be eliminated. Now we have the single mesh. So let's solve a numerical based on this, and then it will be more clear. We have this circuit. So first we'll assign the mesh current. Here we have I1, and here assign it as I2, and here 6 ampere is to common. So first we will discard this element. Now we apply KVL to super mesh from here to here. So applying KVL to super mesh. So here applying KVL to super mesh. So if you like KVL to super mesh, we will go from here to here, means we have 20 minus 6 I1 minus 10, we have this, so minus 10 I2, we have assigned I2 here, and minus 4 I2 equals to 0. So on further simplification we will get here 6i1 plus 14i2 equals to 0. And here we have discarded these elements. So here 6 ampere is in this direction, means here we have the 6 ampere, and I2 is in these directions and I1 is in these directions, means I2, we have here I2 is in the direction of 6 ampere and I1 is opposite to the direction of 6 ampere. So we can write here, since I2 is first in the direction of 6 ampere, so I2 minus I1 equals to 6, since we have equation first and equation second. So on solving equation 1 and 2 we will get here the value of I1 and I2. So we'll get here I1 equals to minus 3.2 ampere and the value of I2 will be I2 equals to 2.8 amperes. So these were some tricks and techniques to solve the problem related to mesh analysis and also to solve the concept of supermesh. Hope you enjoy the lectures. Thanks for watching this lectures. And if you liked it, please don't forget to subscribe. Thanks.